Did you know that episodes of elevated climatic temperatures coupled with high relative humidity can result in reduced feed intake, reduced body weight gain, and in extreme cases can cause death of feedlot cattle as a result of hypothermia? A study conducted by Davis and Matter in 2004, titled Effective Management Strategies on Reducing Heat Stress of Feedlot Cattle, investigates the hypothesis that altering feeding time and feed amounts and implementing the use of water sprinkling to feedlot cattle together will significantly reduce heat stress and excessive heat loading, resulting in increased food intake and weight gain. 3 experiments were conducted over 81 days. Experiment 2 did not find any conclusive information, therefore experiments 1 and 3 will be discussed only. 144 Angus crossbred yearling steers, just like these here, were allocated into 3 treatments, each of 8 pens. Group 1 were fed at 8 a.m. daily, Group 2 were fed at 4 p.m. daily, with the leftovers being removed before 8 a.m. the next day, and Group 3 were fed at 4 p.m, but were only given 85% of the feed that was assigned to Group 1. This experiment showed that steers fed at 4 p.m. had a high intake of feed compared to the steers fed at 8 a.m, despite the changing environments.
On a scale from 0 to 2, Table 1 shows the average bung score for Group 2 was 0.3 compared to 0.8 for Group 1.
The lower bung scores for the group fed in the cooler part of the day suggest that altering feeding time to the cooler hours of the day reduces a co-occurrence of metabolic and peak environmental heat loads, occurring all at the same time. And because of the lower heat loads, the animals had a high feed intake. The steers in Group 3 had the lowest bung scores overall.
This is shown here in Table 1 with the average bung score being 0.
This suggests that lowering the amount of feed offered at 85% will reduce bung scores, lower feed intake and reduce weight gain. Experiment 1 indicates that by altering feeding time to the cooler part of the day so that the metabolic and environmental heat loads do not coincide can increase feed intake. In Experiment 3, 192 crossbred steers were randomly divided into 12 pens of 4 treatments. The aim was to determine the combined effects of feeding time and water sprinkling. The treatments included feeding the cattle at 8 a.m. compared to 4 p.m, with water sprinkling and without. The wet steers had a higher overall weight gain when compared to the dry steers.
This is shown here in Graph 1. PM-fed wet steers were 4 kilograms heavier than the PM-fed dry steers, and the AM-fed wet steers were 6 kilograms heavier than the AM-fed dry steers.
These differences in weight gain suggest that the water sprinklers were effective in reducing heat stress and increasing weight gain. This study showed that altering feeding time, feed amount, and the use of water sprinkling to be effective ways of decreasing the risk of heat stress and hypothermia in feedlot cattle.